All right, guys, it's time for science. And today we're doing egg protector. So what that means is we're going to take an egg, and I gave you guys all plastic eggs. That way you don't have to break an egg if you don't want to. But we're going to take it, and we're going to drop it. So what you guys need to do, if I drop this egg, is it going to break?
Yeah.
Yeah. So we're going to try and construct something around it to protect the egg and keep it safe for when we drop it. Okay? Before you guys build, though, we're going to talk about a couple things. So we're going to follow our naming, attending, memorizing, expressing, and storytelling. So first, questions. So if I build a protector around this, it's going to make it heavier. But does a heavier item necessarily fall faster than a lighter one?
Yes.
You think it does? Is gravity the same on a heavier item as it is on a lighter item?
Yeah.
It is the same, right? So gravity technically has the same pull on the items. They're pulling them at the same force. So if I were to drop something like a marble and a marshmallow, which one weighs more?
The marble.
The marble, right? The marshmallow is a lot lighter, but they're roughly the same size. If I drop those at the same time, they'll actually hit the ground at the same time. So the weight isn't a factor when something's being pulled to the earth by gravity. The things that are actually being a factor, so we did this in class, remember? I had a piece of paper, flat like that, and then I had one that we kind of rolled into a cone, and when I dropped them, the same piece of paper, they had the same weight, but the cone hit the ground a lot faster than the piece of paper, right? So it's not about weight, it's about which one is being hit by more air resistance. So this one's hitting all these little molecules of air as it falls, and that's what's slowing it down, not the weight. So that was our first question. And our second, because what affects the rate of falling? Air resistance and aerodynamics. If something is more aerodynamic, like the cone, it's going to cut through the air faster than something that's flatter. So maybe you could have your protector be a little more air resistant. So maybe it'll fall slower than just the egg. All right, now attending. So we're going to make observations. So what do you see? So you guys should all have this piece of paper, and it has a lot of different egg protectors on it that kids have built. So you'll see all the difference. Like here's one that definitely helps with the air resistance, right? It's almost like a little parachute on top. So that's going to slow down that fall. Same with that one. And then these other ones, we're going to talk about these with the rubber bands and stuff. I only used, let's see. So I had rubber bands and popsicle sticks. The next thing I want to talk about before I do this actually is memorizing. So we're going to talk about a couple terms. We talked about gravity already. Gravity is the force at which items are pulled towards the earth. And then we talked about air resistance, right? So the more air that's pushing up, or the more flat an object is to where it's having more air resistance, the slower it's going to fall. The more aerodynamic something is, the faster it's going to fall. And then potential energy and kinetic energy again. As I'm holding this egg right now, it has potential energy, right? The higher I hold it, actually, the more potential energy it has, because the further it's going to fall. So right now it has potential energy. When I drop it, that energy transfers into kinetic energy. So that's energy in motion. Now, do you guys remember what the first law of thermodynamics was? The first law of thermodynamics states that energy cannot be created or destroyed. So you have this potential energy. It's being transferred to kinetic energy. When it hits the ground, that energy has to go somewhere. So when that egg hits the ground, that energy is all going into the egg, and that's what makes it burst open because it's hitting there. So we need something that's going to take up and absorb some of that energy. So something like if I dropped it on a pillow, the pillow can absorb some of that energy, right? Because it's a lot softer and it has more flex to it. It has more elasticity almost. It moves, the energy moves it, okay? So we need something that's gonna help our egg break its fall and absorb some of that energy. So with our popsicle sticks, they've got a little bit of movement in them, right? They look like they could maybe absorb some of that fall, some of that energy. And then the other item we're using is rubber bands. Now they've got a lot of give, right? So they could definitely slow down a lot of that energy and absorb a lot of it as it hits the ground. So you'll notice that these, they use a lot of rubber bands. A lot of these are using rubber bands to help absorb that energy because the energy has to go somewhere. I'll show you my example and then we can just try a couple things for an experiment and then I'll let you guys build on your own. So I did this. I thought maybe when it hits the ground, these popsicle sticks will hit first. I'll rubber band my egg to the top up here to hold the rubber or the egg to this. And hopefully these rubber bands will help absorb some of that energy as it hits the ground. It'll kind of cradle it and hold it. See all that give in there? That's gonna hopefully hold my egg when I drop it. So that's just one idea. You can do anything. Look at all these examples. I love the little parachutes. You could maybe use coffee filters or just whatever you have at the house. These straws are probably really good. They have give. They're not super hard. You wouldn't want to just put it, oh, I'm going to put this egg in a wooden box and drop it because the egg's still going to hit this hard wood on the sides, right? It needs to be cushioned by something soft. So think of what materials you can use and I'll let you watch mine and see what happens. It might break, I don't know. But we'll give it a shot and then you guys will be off to do your own. And then for storytelling, you guys will do presentations and you guys will show us your egg protector and you can demonstrate it. It's up to your parents. You can use a real egg if you have extra ones. My neighbor across the street has chickens, so we have tons of eggs. Or you could use the Easter egg that I gave you guys. So up to you. Let's go outside and see how this contraption does.
Let me get up. Okay. All right, so we're gonna drop our egg right here. So first I'm gonna drop the regular egg without the egg protector. It has potential energy. Do you think it's gonna break? And it definitely broke a lot. Didn't just crack, it completely broke open. So now let's see if I did a good job trying to protect my egg. Drop it from the same height. Oh, it fell sideways, so it couldn't protect itself. I think it would have been helpful if I had maybe the parachute on top to keep it from turning sideways. All right, you wanna drop yours, Ryder? Look out, B. Can you hold that to the side? Make sure you have it all the way over the frying pan, Ryder. Right now, you're gonna hit the side of it. Look out, B. Okay. Oh, see?
It's gonna break?
It did break. So none of ours worked. I hope you have better luck.